So for this section, we have this to be on JavaScript Maths, and this particular section covers some mathematical functions in JavaScript. Now, I know in the past we've done arithmetic operators which serve their own functions, the addition, subtraction, division, and some other functions they do. But then this particular JavaScript Maths here actually does some form of calculations that are limited to the arithmetic operators. So, for instance, you want to find the square root of something, the cube root, or the logarithm, sine, cosine, and some of these, you know, mathematical expressions. The arithmetic operators can't really do those things, but with JavaScript Maths, you can actually do things like that. So, what is JavaScript Maths? JavaScript Maths here is an inbuilt object that allows a user to perform mathematical operations on numeric values. So this is what the JavaScript Maths basically is. And here you can see that it's inbuilt. So this means that it comes with JavaScript. You don't need to download or import or create anything. So very briefly, we have the math properties. And these properties here are constants in mathematics that cannot be changed. So many of us might remember that in mathematics, there are actually some constant values that can never be changed. For instance, you have what we know as pi, which is 22 over 7 or 3.142. That's, rounded up just in three significant places. That's actually just 3.142. So values like that, also the Euler's number and some other constants in mathematics, you can actually do this by using the math properties. But here JavaScript actually is limited to just 8 properties. So this means that JavaScript has just 8 constants. And on the screen we can see the syntax here. It's very straightforward. And for the syntax you would need in order to make use of these properties, it begins with the math keyword and then you attach the property to this keyword. So by attaching the property to this keyword, you would actually get the constant you want. So here are some brief examples of constants we have in JavaScript. Like I said before, JavaScript doesn't have everything. It's quite limited to just 8 of them. But then some of the popular ones in JavaScript is actually the Euler's number. And to make use of this constant, it begins with the math keyword and .e. And so by assigning this to any variable name, the variable name here would hold the constant of the Euler's number. Also, we have math.pi, and this particular one would return pi. That's the 3.14 to wherever it ends. It returns this one. And if you notice very well, each of these examples doesn't have anything attached to it, like a variable name or parentheses. No, the syntax here is straightforward. We also have the math dot square root 2. This would return the square root of 2. And we also have the math dot square root of 1 over 2, which is written as math dot sqrt 1 underscore 2. So I said before that the properties here are limited. Anyway, you can't have the entire constant in maths in JavaScript. So for the ones that are not here, you would need to, create them on your own. But then JavaScript has some already you could make use of if you need them. So the next thing we have here is the math method. Now these methods are used for performing mathematical operations on numbers. So you can say that these particular methods they actually perform similar operations to the arithmetic operators. But like I said before, arithmetic operators are only limited to some basic arithmetic operations. That's your basic addition, subtraction, division, multiplication, experimentation, and the rest. But here with these methods, we can actually compute some advanced mathematical calculations that involve logarithm, cosine, sine, arcsine. Some of these particular calculations we want to do in maths can be done by making use of the math methods. And you can see the syntax on the screen, also straightforward. It begins with the math keyword. Now after the keyword, you have the name of the method you want to make use of. So imagine if I wanted the logarithm of a number, the method name here would be dot log. And within the parentheses where you see number is where you would input the number you want to find the logarithm for. So that's how easy this is. So here also are some brief examples of the methods in maths. And on the first example, you can see that to be log with the parentheses and 2 being inside it. So this particular method would return the logarithm of 2. Next, we have the truncation method. Now, this particular one actually works with float values. And what this will do is that it's going to return the integer part of any float value. So here we have 4.5, which is a float value. But then the integer part here is actually 4. So this particular example would return 4 as the result. So for the next one, we have this square root method, which has its syntax to be in sqrt and also a parenthesis. So the parenthesis here would hold the value you want to find the square root of. Now you can see that using this particular method is actually better than using the properties, because within the properties you only have a defined square root of 2 and 1 over 2. There are no constants for other numbers. But with this method you can find the square root of any given value you want. Also we have the cube root, which has a syntax to be in cbrt. It also has the parentheses attached to it, and inside there is where you would put the number you want to get the root of. So for some other types of operations that involve sine, cosine, and tangent, it's also possible in JavaScript Maths. And so for the first example, which is sine 30, this would return the sine of 30, but not in degrees. It will return the sine of 30 in radians. So if you want it to be in degrees, you would need to compute a kind of calculation that would convert the results to another result in degrees. But you can actually still find the sine of 30 in JavaScript, as well as the cosine and as well as the tangent. Also, we have a method that can be used to round up any float value. So for this example, I had this to be round with 4.4 in the parentheses, and this would actually round up the value depending on the decimal number. So the result here would give us 4 because the decimal number here is 4. But if the decimal here was 4.5, it will be rounded up to 5. So before we move on, these are not the only things that JavaScript can do. In fact, there are actually a lot of methods, a lot, so many of them, and we might not be able to explore every single thing. But then just know that with JavaScript methods, you can actually perform some kind of specific calculation in maths. So we've come to the end of, you know, this section of this class. So for this next section, we'll be going into VS Code and we'll be seeing how the maths functions actually work. Okay, so I'll be making use of this same file and I'll be commenting all of this. To be maths functions. Just call this maths. So I'll begin with a constant declaration. And I would begin with the Euler's number. This will be maths dot e. So the reason why this particular um concept is important, it might be very very essential for those who might want to try out creating a simple calculator with JavaScript. Of course, you would need to make use of these methods and also the operators. Okay, so create HTML element for this. I'll call this the Euler's number. Or since it's actually a constant, so the ID name here is just E. We have E dot inner HTML $sign math. And this actually should return the Euler's constant in mathematics. Okay, so here we have it. The Euler's constant is 2.71821828459.045. And after getting this value, you can actually use it to perform a specific operation that you want. So I could go back to my JS and decide to perform something else. I would say let maths to, or I'll call this calculation. Calc equals to math plus 4 in brackets before 7. I'll create another one and I'll call this calculation using Euler's constant. So this should perform a kind of mathematical calculation using the constants we just defined. Okay. Oh, this is after the script file. Okay, so we have this value now. So our calculation here made use of this Euler's constant we've already defined in our program. And we can actually use this to calculate anything we want here. So that's how easy the maths methods actually appear. I mean the maths properties. So another property we have is also the maths.py. Some of us already would know this to be 22 over 7 or whatever. So here we have maths.py and I'll change this to the pi of constant or the pi value. Here we have this to be 3.141592653589793. So this is the entire value for the pi constant. And I could decide to use this to calculate the area of a circle. I believe we already know what that is, or the circumference anyway. So I'll call this constant $sign. It's area. The area of a circle actually is pi r square, if I remember vividly. So this will be $maths asterisk. Let's assume we have a radius of 10. So 10 square would be 10 exponential 2, as we learned when we did arithmetic operators. Okay, I'll change this to pi. So here we have the area of a circle with a radius of 10. But to be sure, I'm going to put this in bracket. So this should still work. Okay, it gives us a lesser value, 25.1327. So I'm guessing the bracket here actually makes the results more precise and not, you know, approximated. Also, we have the maths to the square root of 2. And for this, we'll make use of the maths dot sqrt 2. This would give us the square root of 2. Okay. Square root of 2. Grab a span tag for this. Give this an ID for this SQ2. Inner HTML $sign. Here, this would return the square root of 2, which is 1.4142. So this is how easy you could actually make use of the properties we have in maths. So the next one we'll be trying out is the methods. So we can actually try out the logarithm of a particular number. Hmm. So with log 10. Okay, so here we have the logarithm of 10, and this particular method can be applicable to any number we choose to add. So I could change this to 15, and this gives us 2.7080. Okay, so I'm guessing here is still 10 because we rendered this with HTML. So I'll change this back to 10. Try out truncation. This is represented as math trunc. This particular one would return the integer part of this entire value. Okay, so here we should only have the integer part of this value, and you can see that to be 3 and not the entire value. So this are some of the easiest methods we have in JavaScript Maths. It's one of them. And even if we had this to be an integer type, let's have the value of 3, so it doesn't change at all. So let's imagine we had this to be 0.003. I would expect that this still gives us 0. Yeah, gives us 0. And it doesn't try to, move the decimal point to an actual whole number. Another method we have here is the round method. I'm rounding up 4.4. It would be round. Okay, and so we should expect this to actually round off. So here we have the round of the current value is 4. And this would round off because the decimal value we have is less than 5. So peradventure we had this to be 4.5. Should round up to 5. Yeah. So the rounding of the current value now is 5. And so the last examples we'll be looking at would be the ones related to sine, cosine, and tangent. Sine. Sine 15. Okay, so the sine of the current value of 15 is actually 0.65 to wherever it goes. So this is the sine of 15. Let me change this to 45. Okay, and it gives us this. So this is actually the sine of this current value of 45. And the sine here is actually in radians. So we could also change this to dot cos. That's dot cos, that's for cosine. And we should notice the value actually changed from 0.8509 to 0.5253, and also the tangent, which is dot tan. And this would have 1.619775. So this is how easy the maths method are. And for the last two, we have that to be the cube root and the square root. Also equally easy. Maths dot cube RT square root of 144. Okay, so this should give us the square root of 144. And that's actually 12. So I could change this to what isn't a perfect square. Let's say 110. Okay. Okay, it actually changed. Now we have this to be 10.488088. That's, a float value, since the square root of this doesn't give us a perfect whole number. Likewise, we could also have the cube root. For this, it would be 125. Cube root of this should be 5. Yeah. So I'll change this now to cube root. 125. And we have the cube root of 125 to actually be 5. So here we've tried out some of the methods and properties under JavaScript Maths. So that's how easy and simple and straightforward you could actually make use of these properties and methods. So before we go, let me just see if we could actually show a list of methods we have, because there are actually a lot of them. You can see for any letter you type, you would actually have something show up. There are actually a lot. I think there are about 50 something or 60 something methods out there. And some of them even accept multiple digits. I think the max here does. And so this particular method here would return the maximum number of values that you'd actually put in the parentheses. So let's just have a list of values here. So this should actually return the maximum value we have within the parentheses. And if you look closely, the maximum value here is actually 100 and 1. Here we have this to be 101. So that's another method. And we could also get the minimum value too. So I think for the sake of this, I would actually remove this so as not to cause any confusion. So the minimum value here is actually 12. And that's exactly the value we have here. So you could also try this out for even float numbers. Let's see. So if I save this now, the smallest value here is actually 11.56. Or let me change 11.27. So let's see if this one actually works by giving us this digit and not this one. Yeah, and it also works the same. It gives us our float value of 11.27. Now, mind you, within this parenthesis, you can't have a string value. I wouldn't advise you do this. Shouldn't do this. And you can see that here it gives us NaN. Now, this NaN here actually means not a number. So this means that the math function has already gone through the number of the number of items within the parentheses, because it would have to go through everything first before deciding who really is the smallest here. And so by the time it looks into the entire item within the parentheses, it saw a string there, and a string is not a digit. So this will rather return this than returning the actual lowest number we have there. And even if we had this to be a number string, let me just put 10.4 here. Okay, it gives us 10.4. Yeah, and I'm guessing this is because of the fact that JavaScript actually is a loosely typed language. And aside from that, it means that the particular function here did not really care about the data type. It only looked at the content within the, you know, double quotes, and the content here is digits. Because as you would know, when you render a string on the browser, the string isn't rendered with the double quote, it is only rendered itself. That's the actual content. So this actually rendered 10.4 and did not care if it was a string. But if we had this to be, something like this now, it actually rendered this on the screen, and this on the screen here is not a number in terms of the actual type of value and also the data type. So this would actually cause an error, but having it to be this would give you the same results, because here you have an equal number value as the rest of them, although it has a different data type, which is of a string type. But I'm guessing here that the main function and the max function don't really care about the data type. They just care that the actual content you have within the string is the same content as a number. So this is why this particular one would render on the browser as the lowest value and not an actual, string in letters. So we have 9.3, and if I should put a name here, it wouldn't work the same. It gives us not a number. So I guess that's it with today's class. So I hope we're able to see some of the basic methods in JavaScript. So like I said, The methods are actually a lot more than this. So you would actually need to look into JavaScript and know the actual methods you want to make use of when you want to perform some particular calculations in maths. So that's that for today's class. Thank you.